Understanding Neural Networks, a beginner's guide. Neural networks are a cornerstone of modern artificial intelligence, AI, and deep learning. Inspired by the human brain, they have revolutionized fields such as image recognition, natural language processing, and robotics. For beginners, understanding neural networks can seem daunting, but breaking down the concepts can make them more approachable. Here's a beginner's guide to understanding neural networks. 1. What are neural networks? Neural networks are a set of algorithms designed to recognize patterns. They interpret sensory data through a kind of machine perception, labeling, or clustering of raw input. Neurons, the basic units of a neural network, similar to the nerve cells in the human brain. Layers. Neural networks consist of layers of neurons, typically including an input layer, one or more hidden layers, and an output layer. Weights and biases. Parameters that adjust as the network learns, influencing the output. How they work. Neural networks process data by passing it through multiple layers of neurons. Each neuron receives input, processes it, and passes the output to the next layer. The network adjusts weights and biases through training to improve accuracy. 2. Types of neural networks. Feed-forward neural networks, FNN. Structure. Data moves in one direction from input to output without loops. Simple tasks like basic pattern recognition. Convolutional neural networks, CNN. Structure. Includes convolutional layers that automatically and adaptively learn spatial hierarchies of features from input images. Image and video recognition, object detection. Recurrent neural networks, RNN. Structure. Contains loops that allow information to be carried across neurons while reading in sequences of data. Sequence prediction tasks such as time series forecasting and language modeling. Generative adversarial networks, GAN. Structure. Consists of two networks, a generator and a discriminator, that work against each other to create realistic data. Generating realistic images, video, and other media. 3. Key concepts. Activation functions. Determines if a neuron should be activated or not. It introduces nonlinearity into the model, helping the network learn complex patterns. Common functions. Process of moving input data through the network to generate output. Loss function. Measures the difference between the network's prediction and the actual result. Backpropagation. Algorithm used to minimize the loss function by adjusting the network's weights and biases. Epochs and batches. Epoch, one complete pass through the entire training dataset. Batch, a subset of the training data. Training is often done in batches to improve computational efficiency. 4. Steps to build a neural network. Step 1. Data preparation. Collect data, gather and pre-process data relevant to the problem you're trying to solve. Normalize data. Scale data to ensure it fits within a certain range, improving network performance. Step 2. Define the network architecture. Input layer. Specify the number of input neurons based on your dataset. Hidden layers. Determine the number and size of hidden layers. More complex tasks typically require more layers. Output layer. Specify the number of output neurons based on the problem, one for binary classification, multiple for multi-class classification. Step 3. Choose an activation function. Select appropriate activation functions for the hidden and output layers. Step 4. Compile the model. Loss. Function, choose a loss. Function to measure how well the network is performing. Optimizer. Select an optimization algorithm, stochastic gradient descent, to adjust weights and biases. Metrics. Decide on metrics to evaluate the model's performance. Step 5. Train the model. Feed data. Provide the training data to the model. Adjust weights. Use backpropagation to minimize the loss function over multiple epochs. Step 6. Evaluate the model. Testing data. Use a separate dataset to evaluate the model's performance. Fine-tuning. Adjust hyperparameters and retrain if necessary to improve performance. 5. Practical applications. Image recognition. Neural networks are widely used in image recognition tasks such as identifying objects in pictures, facial recognition, and medical imaging. Natural language processing, NLP. They power applications like language translation, sentiment analysis, and chatbots by understanding and generating human language. Autonomous vehicles. Neural networks help self-driving cars interpret sensor data, recognize objects, and make driving decisions. Financial forecasting. Used for predicting stock prices, assessing credit risk, and detecting fraudulent transactions. Neural networks are a fundamental component of AI, enabling machines to perform complex tasks with high accuracy. By understanding the basic concepts, types, and applications of neural networks, beginners can start exploring this exciting field. With a wealth of resources available, anyone can begin their journey into neural networks and contribute to the ever-evolving landscape of artificial intelligence.